हेलो एवरीवन। दिस इज संतोष। गुड इवनिंग टू ऑल ऑफ यू। आज हम लोग डिस्कस करने जा रहे हैं एजेंटिक एआई का एक नया लेक्चर, जिसमें कि हम लोग डिस्कस करेंगे एजेंटिक एआई के कुछ और फीचर्स के बारे में। ठीक है, सो लेट्स स्टार्ट। सो at the intersection of AI, distributed systems, and software engineering lies a powerful paradigm known as Agentic AI. As we know, Agentic AI is all about the distributed system, and software engineering lies on a powerful paradigm. So, this new generation of intelligent system consists of the software agent and that are capable of adapting behavior, complex coordination, and delegated decision making. This guide introduces the principles that define modern software agents and outlines their evolution towards agentic AI. To explain this shift, the guide provides the conceptual background and then traces the evolution of software agent to agentic AI. Introduction to software agents. Define software agents, compare them to traditional software components, and introduces the essential characteristics that differentiate agentic behavior from traditional automation by drawing from the established frameworks. The purpose of software agents examine why software agents exist, what roles they fulfill, what problems they solve, and how they enable intelligent delegation, reduce cognitive load, and support adaptive behavior in dynamic environments. The evolution of software agents traces the intellectual and technological milestones that shaped software agents. So, from the early concept of the autonomy and concurrency to the emergence of multi-agent system and formal agent architecture resulting in the convergence with the generative AI. Software agents to agentic AI. That introduce agentic AI is the culmination of the decades of the progress that combines distributed agent models with foundations models, serverless compute, and orchestrations protocols. This section describes how this convergence enables a new generation of intelligent tool using agents that operate with autonomy and asynchronicities and true agents at scale. So, intended audience. This guide is designed for the architect, developers, and technology leaders who want to understand the history, main concept, and evolution of software agents to agentic AI before they adopt this technology for modern cloud solution on Amazon's web services. So, this is the documentation. We are going to, with the help of this documentation, we will discuss the agentic AI, and this is related to AWS, Amazon Web Services. So, adopting agentic architecture help organizations accelerate time to values, automate and scales knowledge work, and reduce manual effort and latency. So, as we already discussed that agentic AI is all about automation and scaling the knowledge work and reduce the manual efforts. So, improve customer engagement, deliver intelligent assistance across domains, and reduce operational cost, automate decision flows that previously required human input or oversight, drive innovations and differentiations, build intelligent products that adapt, learn, and compete in real time, modernize legacy workflows, reframe scripts and monoliths into the modular reasoning agents. About this content series, this guide is a part of the series about agentic AI on AWS. For more information and view the other guides in this series, agentic AI on AWS Prospective Guideline website is there. You can watch there also. So, introduction to the software agent. What is the software agents that helps or minimize human efforts? The concept of the software agents has evolved significantly from its foundations in autonomous entities in the 1960s to its formal exploration in the early 1990s. As digital systems grow increasingly complex from the deterministic script to adaptive intelligent applications, software agents have become essential building block for enabling autonomous, context aware and goal driven behavior in computing systems. In the context of the cloud native and AI enhanced architectures, particularly with the advent of the generative AI large language models and platforms such as Amazon Bedrock, software agents are being redefined through new lenses of capabilities and scale. These introductions draw from the seminal work Software Agents and overview by the this this person. It defines software agents, discusses their conceptual roots and extends the discussion into a contemporary framework to define three overarching principles of modern software agents: autonomy, asynchronicity, and agency. These principles distinguish software agents from the other types of services or applications and enable these agents to operate with the purpose, resilience, and intelligence in distributed real-time environments. So, in this section, from autonomy to distributed intelligence, Navana typology and the rise of the software agents and the three pillar of the modern software agents. So these three we will discuss from autonomy to distributed intelligence. Before the term software agent entered the mainstream, early computing research explored the idea of autonomy digital entities and which are the systems that are capable of acting independently, reacting to inputs and making decisions based on the internal rules or objectives. These early ideas laid the conceptual groundwork for what would become the agent paradigm, and the second one is early concepts of autonomy. The notion of machine or the program that act independently from the human operators has intrigued system designer for decades. Early work in the cybernetics, artificial intelligence, and control systems. The examined how software could exhibit self-regulatory behavior, respond dynamically to changes, and operate without the continuous human supervision. These ideas introduce autonomy as the core attributes of intelligent systems and set the stage for the emergence of software that could decide and act instead of only reacting or executing. The actor model and asynchronous executions. In the 1970s, the actor model, which has introduced in the paper a universal model actor formalism for the artificial intelligence, provided a formal framework for thinking about decentralized message driven computational. In this model, actors are independent entities that communicate exclusively by passing asynchronous messages and enable scalable, concurrent, and fault tolerant systems. The actor model emphasizes three key attributes that continue to influence modern agent design: isolation of states and behavior, asynchronous interactions between entities, and dynamic creations and delegation of tasks. These attributes aligned with the need of distributed systems and prefigured the operational characteristics of software agents in cloud native environments. So distributed intelligence and multi-agent system as computing system became a more interconnected after 1960. Researchers explored distributed artificial intelligence. This field focused on how multiple autonomous entities could work collaboratively and competitively across a system. DAI lead to the development of multi-agent system where each agent has a local goals, perceptions and reasoning but also operates within a broader interconnected environment. This vision of distributed intelligence where decision making is the decentralized and emergent behavior arises from the agent interactions remains central to how modern agent based systems are conceived and built. Nirvana typology and the rise of software agents. The formalization of the software agent concept in the mid 1990s marked at the tuning point in the evolution of intelligent systems. Among the most influential contributions to the formalizations is in which provide one of the first comprehensive framework for categorizing and understanding software agents across various dimensions. In this paper, Navana surveyed the state of software agent research and identify a growing divergence in how agents were being defined and implemented. The paper highlights the need for a common conceptual framework and possess a typology that classify agents according to their key capabilities. It reviews representative agent system from academia and industry, distinguishes agents from the traditional program and objects, and outline the challenges and opportunities in the agent-based computing. Navana emphasizes that software agents are not a monolithic concept but exist along a spectrum of sophistications and capabilities. That typology serves to classify these landscapes and guide future design and research. Navana defines a software agent as a software entity that functions continuously and autonomously in a particular environment, which is often inhabited by the other agents and processes. This definition emphasizes two key characteristics: continuity, the agent operates persistently over the time without requiring constant human intervention. Autonomy, the agent has the capability to make decisions and act on them independently based on its perception of the environment. This definition, combined with the Nirvana agent typology, emphasizes delegated authority and proactivity as the foundational characteristics of agents. It differentiates between the agents and the subroutines or the services by highlighting the agent ability to act independently on the behalf of another entity and to initiate behavior, its pursuit of goals instead of only responding to direct commands. Navada agents typology to further differentiate among various type of agents. Navana introduces a classification system based on the six key attributes. Autonomy, the agent operates without direct intervention from humans to or others. Social ability, the agent interact with other agent or humans by using communications mechanism. Reactively, the agent perceives its environment and responds in a timely manner. Proactively, the agent exhibits goal-directed behavior by taking the initiatives, adaptabilities, and learning. The agent improves its performance over time through experience. Mobility, the agent can move across different system environments or networks. From typology to modern agentic principles, Navana works served as both a taxonomy and the foundational lens through which the computing communities could evaluate the evolving forms of agency in software. His emphasis on autonomy, proactivities, and the concept of acting on the behalf of user of system led the groundwork for what we now consider agentic behavior. Although the technologies and environments have changed, especially with the rise of generative AI, serverless infrastructure, and multi agent orchestrations frameworks, the foundational insights from Nirvana work remain relevant. They provide a critical bridge between the early agent theory and the three modern pillars of software agents. The three pillars of modern software agents in the context of the today AI-powered platforms, microservice architectures, and event-driven systems, software agents can be defined by the three interdependent principles that distinguish them from the standard services or automation script autonomy, synchronicity, and agency. In the following illustrations and in the sequent diagrams, the triangle represent these three pillars of the modern software agents. So this is the diagram. Agency is there, autonomy is there, and asynchronicity is there. Both three among three of them, they are interconnected. Agency with autonomy and autonomy with asynchronicity and asynchronicity with agents. So autonomy, what about the autonomy? So modern agents operate independently. They make decisions based on the internal state and environmental context without requiring human prompts. So it is all about independence. So this enables them to react to the data in the real time, manage their own life cycle, and adjust their behavior based on the goals and the situational input. Autonomy is the foundation of agent behavior. It is about behavior. It's allow agent to function without continuous supervision or hard-coded control flows. So asynchronicity agents are fundamentally asynchronous. This means that they are respond to event signals and stimuli as they occur without relying on the blocking calls or the linear workflows. These characteristics enables scalable non-blocking communication, responsiveness in distributed environments, and the loose coupling between the components. Through asynchronicity, agents can participate in real-time systems and coordinate with other services or agents fluently and efficiently. Agency as a defining principle. So autonomy and asynchronicity are necessary, but these features alone are not sufficient to make a system true software agent. The critical differentiator is agency. So agency is the key things which introduce goal directed behavior. Agents pursue objectives and evaluate progress towards them. Decision making agents access options and the choose actions based on rules, models, or the learned policies. Delegated intent agents act on the behalf of a person, system, or organizations and have an embedded sense of purpose. Contextual reasoning agents incorporate memory or models of their environment to guide behavior intelligently. A system that is autonomous and asynchronous might still be reactive service. What makes it a software agent is its ability to act with the intentions and purpose to be agentic. So agency with the purpose. The principle of autonomy, asynchronicity, and agency enable system to operate intelligently, adaptively, and independently across distributed environments. These principles are rooted in the decades of conceptual and architectural evolutions and now underpin many of the most advanced AI systems being built today. In this new era of generative AI, goal-oriented orchestrations, and multi-agent collaborations, it is essential to understand what makes a software agent truly agentic. Recognizing agency as the defining characteristics help us move beyond automations and into the realm of autonomous intelligence with purpose. So, purpose of the software agents. So, these are the purpose we are defining as modern systems have become increasingly complex. One second. Distributed and intelligent, the role of software agents has gained prominence across domains and range from the autonomous operations to user assistive technologies. But what is the underlying purpose of the software agents? Why do we design systems that go beyond scripts, services, or static models and instead delegate tasks to entities that are capable of perceiving, reasoning, and acting? These sections explore the fundamental purpose of software agents to enable intelligent delegations of tasks within dynamic environments with a focus on autonomy, adaptability, and purposeful actions. It introduces the conceptual foundation of software agents, traces their cognitive structure, and outlines the real world problem that they are uniquely equipped to solve. In this section, from the actor model to agent cognitive, the agent function, perceive, reason, and act autonomous collaboration and intentionality. From the actor model to agent cognitions, the purpose and the structure of the software agents are grounded in the idea that emerged from the early computational models, particularly the actor model that was introduced by the Carl Havitt in 1970. The actor model treats computational as a collection of independent, concurrently executing entities called actors. Each actor encapsulates its own state, interacts slowly through the asynchronous message passing, and can create a new actors and delegate tasks. This model provides the conceptual foundation for the decentralized reasoning reactivities and isolations, all of which underpin the behavior architecture of modern software agents. The agent functions, perceive, reason, and act. At the core of every software agent is the cognitive cycle that is often described as the perceive, reason, act loop. This process is illustrated in the following diagram. It defines how agents operate autonomously in dynamic environment. So this is the perceive and based on actions. So in middle we have a reason for the goals, plan, library, and intentions and beliefs. So this is the flow diagram to perceives to actions. So reason are these force environment. So what we perceive, agents gather information. So they gather information, for example, event, sensor input, or API signals from the environment and update their internal state and beliefs. Reasons, we have a reason and action. So in the reason, in the middleware, we have a reason. So, reason agents analyze current belief, goals, and contextual knowledge by using a plan library or logic system. This process might involve goal prioritizations, conflict resolutions, and intention sections. So, we have an action. Agents select and execute action that move them closer to achieving their delegated goals. This architecture supports the ability of agent to function beyond rigid programming and enables flexible, context sensitive, and goal directed behavior. It forms the mental framework that guided the broader uh, purposes of software agents, autonomous collaboration, and internationality. So, the purpose of software agents is to bring autonomy, context awareness, and intelligent delegation to modern computing. Because agents are built on the principles of actor model and embodies in the perceive reasons act cycle, they enable systems that are not only reactive but proactive and purposeful. Agents empower software to decide, adapt, and act in a complex environments. They represent users, interpret goals, and implement tasks at machine speed. As we move deeper into the era of agentic AI, software agents are becoming the operational interface between human intent and intelligent digital actions. Delegating intent. So, delegating intent, we have a unlike traditional software component, software agents exist to act on the behalf of something else. A user, another system, or a high level service that carry delegated intent, which means that they operate independently after initiations. Make choices that are aligned with the goals of the delegator, navigate uncertainty and trade off in the execution. Agents bridge the gap between the instructions and outcomes, which allow user to impress intent at a higher level of abstractions instead of requiring explicit instructions. Operating in a dynamic under so, unpredictable environments. Software agents are designed for the environments where conditions change constantly and data arrives in the real time and control and the contexts are distributed. Unlike static programs that require exact input or asynchronous execution, agents adapt to their surrounding and respond dynamically. This is a vital capability in cloud native infrastructure, edge computing, IoT, Internet of Things, networks, and the real time decision making systems. Reducing human cognitive load. One of the primary purpose of software agent is to reduce the cognitive and operational burden on humans. Agents can continuously monitor system and workflows, detect and respond to the predefined or emergent conditions, automate repetitive high volume decisions, and react to the environmental changes with minimum latency. When decision making shifts from the user to agent, system become more responsive, resilient, and the human centric and can adapt in a real time to new information or disruptions. This enables faster reactions, turnaround, as well as greater operational continuity in high complexity or high scalability environments. The result is to shift in the human focus from micro level decision making to strategic oversight and creative problem solving. So, enabling distributed intelligence, the ability of the software agent to operate individually or collectively, enable the design of multi-agent system that coordinate across environment or organizations. So, it can interact with within the environment or organizations. Enable distributed intelligence. Further, this these systems can distribute tasks intelligently and negotiate, cooperate, or compete towards composite goals. For example, in a global supply chain system, individual agents manage factories, shipping warehouses, and last mile delivery. Each agent operates with local autonomy. Factory agents optimize production based on the resource constraints. Warehouse agents adjust inventories flows in a real time, and delivery agents reroute shipment based on the traffic and customer availabilities. These agents communicate and coordinate dynamically and adapt to distributions such as the port delays or the truck failures without centralized control. The system overall intelligence emerges from these interactions and enable resilient, optimized logistics that are beyond the capabilities of a single component. In this model, agents act as the nodes in a broader intelligence fabric. They form emergent systems that are capable of solving problems that no single component could handle alone. So, acting with a purpose, not only reactions. Automations alone is insufficient in complex system. So with automation, we have some different things also. The defining purpose of a software agent is to act with a purpose and to evaluate goals, back context, and make informed choices. This means that software agents pursue goals instead of only responding to the triggers. They can revive beliefs and intentions based on the experience or feedback. In this context, beliefs refer to the agent's internal representation of the environment based on its perceptions. Intention refer to the plan that the agent chooses to achieve a goal. Agents can also escalate, defer, or adapt actions as necessary. This intentionality is what makes software agents not just reactive executor but autonomous collaborator in intelligent system. The evolutions of software agent. So we will discuss the evolution of software agents. The journey from the simple automated system to intelligent, autonomous, and goal directed software agents reflect decades of evolution in computer science, artificial intelligence, and distributed systems. This evolution was followed by the rise of machine learning, which shifted the paradigm from the handcrafted rule to statistical pattern recognition. These systems could learn from the data and enabled advances in the perception, classifications, and decision making. Large language model represent a convergence of scale architecture and the unsupervised learning. You can learn this supervised and learn unsupervised learning from the last lectures. So large language model can reason, generate and adapt tasks with a little or no task specific training. By combining large language model with scalable cloud native infrastructure and composable architectures, we are now achieving the full vision of Agentic AI. Intelligent software agent that can operate with the autonomy, context awareness, and adaptability as enterprise scales. So this is the graph. In this section, we explore the history of software agents from the foundational theory to the modern practice as illustrated in the following diagram. It's highlight the convergence of distributed artificial intelligence and transformer-based generative AI and identify the key milestones that have shaped the emergence of agentic AI. So it is all about attention in all you need is uh, 2017. And in 2022, ChatGPT introduced. 2023, open source large language model has came. So it is ChatGPT came around 2022. And the study of the distributed AI came into the 1977, 1990, and 1996. So this is the all the historical representation of what we got in this sections. So foundation of software agents and maturing the field from the reasoning to actions, a parallel timeline, the rise of large language model, and timelines convergence, the emergence of agentic AI. So foundations of software agents. So this is the birth of autonomy in the software, and the root of software agent trace back to this. We introduce the concept program that are capable of perceiving their environment and acting independently. So this is multi-agent system maturing the field from reasoning to the actions. This is all about these things. So Michael Ward Rice and Nicholas Jennings, the agent spectrums formalizing the agent concept, how we formalize, which provide the most comprehensive classification of agents to date. His typologically included distributed such as the autonomy, social ability, reactivity, proactivity, learning, and mobilities, and differentiated between the software agent and the traditional software constructs. Nirvana also offer a now widely accepted definitions. Paraphrased, a software agent is a software-based computer program that acts for a user or the other program in a relationship of agency, which derives from the notions of the delegation. This formalization was instrumental in the transitioning software agents from theoretical construct to the real world applications. So this is all parallel timeline, the rise of large language model. So transformation happened in 2017. The paper Attention is All You Need introduced the transformation architecture, which dramatically improved how machine process and generate language. In 2022, ChatGPT OpenAI released a chat-based interface to ChatGPT 3.5 called ChatGPT, which enabled natural interaction conversations with a general-purpose AI system. In 2023, open source LLM, the release of Llama, Falcon, and the Mistral made powerful models widely accessible and accelerated the development of agent framework in open source and enterprise environment. These innovations turned language model into the reasoning uh, engines that are capable of parsing context, planning actions, and chaining responses, and LLM become key enabler of the intelligent software agent. So, this is all about today, and we will discuss this thing in the next lecture. So, till that time, you can enjoy it. And if you like this video, you can like, share, and subscribe. Thank you for watching. Goodbye. Jai Hind, Jai Bharat.